Welcome to Ganitika.com, a website for mathematics lovers, learners, and leaders. In the series of videos for IB, DP Maths, AA, HL, and SL, we are going to deal with the past paper questions on exponents and logarithms today. And in this video, I'm not going into the exponential and logarithmic functions, but I'm going to do the basic algebraic concepts on exponents and logarithms. So we will be using the rules of exponents and the rules of logarithms in these questions. The questions under exponential and logarithmic functions will be dealt when we are doing functions and calculus past paper questions. Proceeding with this video, from the formula booklet that you should be having in front of you now, we have these formulas given in the booklet. For SL 1.5 and SL 1.7, exponents and logarithms are under the SL syllabus. Therefore, this is common for both standard level and higher level students. The first set of rules we have here are the ones which will help us to convert from exponential to logarithmic and logarithmic to exponential form. The next set is the rules of logarithms. Unfortunately, we don't have rules of exponents in this formula booklet. I'll be giving those rules as well soon here in this video in few minutes. But before we go further, another set of rules that we have in the booklet is under the functions topic SL 2.9, and this gives you the properties of logarithmic in E and ln form as well as in base A form. So for these two properties, you need to basically understand that e to the power of ln A is A, because E and ln are inverse functions to each other. Therefore, e to the power of ln A gives you the A. Another thing that you need to know here is log of A base A is equal to 1 always. Whatever A is, log of A to itself is equal to 1. These are the two things that you need to understand in order to understand the SL 2.9 part of the topic. And of course, you should have a book and pen with you and a graphing calculator in order to solve paper 2 questions. Now let's see the rules of exponents that you should have learned earlier. A to the power of m times a to the power of n is equal to a to the power of m plus n, and so on. And another set of rules for exponents is a to the power of negative m is equal to 1 over a power m. A to the power of 1 over m is mth root of a, and a power 0 equal to 1. So these are the 6 rules that you need to know before you proceed further. Please take this down in your notebook and remember this, because this is not in your formula booklet. So let's proceed further. This video is split into two parts, paper 1 and paper 2. Under paper 1, you have some questions, number 1, number 2, number 3, 4th, 5th and 6th question. As I said, the questions are common to both SL and HL students. This is under paper 1 from past papers. And under paper 2, we have only 2 questions. The second question is the one which you will be using the calculator for, and the first question you may not be using the calculator. So even though this is in paper 2, you will not be able to use calculator for the first question, but you have to be using the calculator for the second question. So what you can do here is pause the video, try to solve all these problems in your notebook, and then continue with the video for the solution as well as the marking scheme. So let's proceed further with paper 1 questions. The first question is, find integer values of m and n for which m minus n log 2 base 3 is equal to 10 log 6 base 9. You can see that the left hand side has a log to base 3 and the right hand side has the log to the base 9. Therefore, you have to use the change of base rule in order to change one of the bases to the other. It is easy to change the base 9 to base 3, as here log 6 base 9 is equal to log 6 base 3 divided by log 9 base 3. And log 9 base 3 can also be simplified further using this rule, because 9 is 3 to the power of 2, right? So when you write 9 as 3 to the power of 2, log 9 base 3 will be 2 log 3 to the base 3. And we also know that log 3 base 3 is 1. Therefore, the denominator there becomes 2. So this expression becomes 10 times log 6 base 3 divided by 2, which in terms gives you 5 log 6 base 3. So this is what you need to change first before you write down the question again. M minus n log 2 base 3 is equal to log 6 base 3. Now both the sides have the log to the base 3. Now you will move the logs to one side and keep the m to the left hand side. Each term on the right side can be simplified using this formula. N log 2 is log 2 to the power of m. 5 log 6 is log 6 to the power of 5. So you can use this formula and simplify that. And also you can use this formula to simplify this further, making the sum of the log into the log of product. So 2 power n times 6 power n for log to the base 3 is equal to m. Now we have simplified the given expression to m is equal to log of 2 power n 6 power 5 base 3, where you have only one logarithmic term on the right side, one variable on the left side. Now we will use this conversion from exponential to logarithm and logarithm to exponential form. In this case, we will be converting the logarithm to exponential form. 3 is the base, m is the power, and the value on the right hand side should be 2 power n 6 power 5. Now what I will do here is I will bring the 2 power n to the left hand side and keep the 6 power 5 on the right hand side, and I will change the 6 power 5 to 3 times 2 to the power of 5, which invariably gives you 3 power 5 times 2 power 5. And then I will move the 2 power n in the denominator to the numerator as 2 to the power of negative n. So basically what I am doing is I am writing 3 power something, 2 power something on both the sides, so that I can equate the bases of 3 together, making m is equal to 5, and equate the bases of 2 together and making minus n equal to 5, which makes n equal to negative 5. So these are the values for m and n. M is 5 and n is negative 5. It's a very simple question, but you are using lots of rules of logarithms here. You might find another simpler method than this. That's fine for you, but I'm going to give you a marking scheme now. You will understand how to mark your own work. So this is method 1 mark for changing the log 6 base 9 to log 6 base 3. Using the change of rule formula is a method mark, and simplifying this into an exponential equation is a method 1 mark. So there is a method 1 mark for writing both the sides in same base, and answer 1 mark for both m and n. So in this case, A1 mark for both m and n together. If one of them was wrong, you will not get this last mark A1. So let's proceed further to the next question. Solve the equation logarithm of x plus 3 to the base 2 plus logarithm of x minus 3 to the base 2 is equal to 4. Luckily, we have both of them in the same base, so we can directly use the formula for sum of the logarithms is equal to logarithm of product rule. I'm not going to show you the rules anymore. We know what rule we are using. So now we need to convert this to exponential form like this. And what we need to know here is the algebraic identity a plus b times a minus b is equal to a square minus b square. There are 3 algebraic identities which you should be knowing by heart. If you do not know these algebraic identities, there is a link to the video in the description box below that explains all these 3 identities in a nice way. Now x plus 3 times x minus 3, using this identity would be x square minus 9. On the right hand side it will be 16 for 2 to the power of 4. Now you can simplify this and find x value as plus or minus 5. That's easy. But here, since this is a logarithmic equation, you have to stop here and think whether it is plus 5 or minus 5 for the answer, or both. So let's consider plus 5 first. Now we have logarithm of x plus 3 and logarithm of x minus 3. So what is x plus 3 when x is equal to 5? It is positive. X minus 3 when x is equal to 5, it is positive as well. So both the logs are going to be positive. Therefore, it's okay to use x is equal to 5. Let's check for x is equal to negative 5. Both x plus 3 and x minus 3 are negative, but logarithm of negative number is not possible. Therefore, x minus 5 is not a solution. So the answer is just x is equal to plus 5 only. So this is what you need to know. You should not stop the question at plus or minus 5. Whenever you have a logarithmic equation, after getting the values of x, you have to go back to the equation, check which of the solutions will give you positive values inside the logarithms, and give that answer and reject the answer which gives you the negative values inside the logarithms. So going for the marking scheme, using the sum rule to product, method 1 mark, and simplifying this into a quadratic equation, method 1 and answer 1 mark. Getting plus or minus 5 for x is answer 1 mark. You can see that out of 5 marks, you have 4 marks up to this stage. And identifying only one answer gives you 1 mark. So the last 1 mark is going to be for giving just 5 and rejecting negative 5. There might be an R1 mark for rejecting negative 5 sometimes. Do not miss those 2 marks in the end. Be careful in logarithmic equations. You have to choose the correct value so that the value inside the log is positive. Let's go to the next question. Solve ln x the whole square. Be careful. Ln x the whole square is not equal to 2 ln x because it's the whole square for all of them together, ln x. It's not ln of x square. The square is for ln x as such. So ln x the whole square minus ln 2 times ln x is less than inequality 2 ln2 whole square. You can see that ln2 on both the sides is a constant. So you have a ln x the whole square minus ln2 times ln x. And then I'll bring the minus 2 ln2 whole square to the left hand side and make it as less than 0 to make it as a quadratic inequality in ln x. You can continue using ln x as such or change ln x as y and change the equation in terms of y so that it looks much better than the original equation. Now you have to solve for y. Using the formula or any other method, you can find that y is going to be equal to ln2 plus or minus 3 ln2 over 2. So ln x is y is equal to 2 ln2 or ln4. The another value for y is minus ln2. Minus ln2 is ln of 2 to the power of minus 1, which is ln of half. But we are not done yet. We have ln x as y. So ln x is equal to ln4, which gives you x is equal to 4. And ln x is equal to ln half, which gives you x is equal to half. We are not still done yet because this is an inequality question. So we have to give the answer in inequality. For less than 0, the quadratic is going to be below the x-axis for between the roots. So half to 4 for x values will give you the inequality less than 0. So the x value between half and 4 will be the solution for this inequality. For quadratic inequality, there is a video in the description box below. If you have not learned that before, please check that video, watch the video carefully and then come back to this question again. So this is for method 1 for writing this as a proper inequality in quadratic. Solving the quadratic A1 mark. Finding the values for y as ln4 and ln half A1 mark. Getting the x values from those two values gives you m1 and a1 mark, and giving the final inequality answer a1 mark. So we have 6 marks for this question. This is easier if you know how to solve quadratic inequalities. Next question is solve the simultaneous equations, and two equations are given. I'm not going to read it out. 2 equations are given and we have to collect all the logarithms to one side in both the equations. So we'll do it for the first equation and simplify using the logarithmic rules. So 2 log y becomes log y square there, and then subtraction becomes division, and then using the change of logarithm to exponential form, 6x divided by y square is equal to 2. Rearranging, y square is equal to 3x. Keep it safe for the next equation. So rearranging the next equation and using the rule of subtraction to division and changing to exponential form and writing this x as y square over 3 from this section and multiplying y square over 3 on both sides, we get this equation in y as a quadratic equation. You can solve this quadratic equation. You can use any method, factorization or using the formula or any other method you want, you can use it. And the value for y is going to be 5 by 2 and 5. Now you have to find the value for x corresponding to each values of y. So for this 5 by 2, you will get x is equal to y square over 3, which is going to be 25 over 12 for x. And for y equal to 5, x is going to be equal to 25 over 3. Therefore, you have 25 over 12, 25 over 3 for x and 5 over 2, 5 for y. Now the marking scheme is method 1 mark for rearranging and writing it in a proper way and getting the x and y in terms of each other, and rearranging the second equation, getting the equation correctly in terms of x and y, and changing the equation in one of the variables, either all of them in x or all of them in y. Now we have changed all of them to y in this case, and solving for x and y, first x and y, and the value for second x and y gives you another a1 mark. So this is all for this question, and we'll move on to the next question now. I hope you got these values correctly when you were solving them by yourself. So the next question looks a little bit bigger, but the questions are really small and simple. What you need to know is this is a geometric sequence, has a common ratio r, and there is another sequence given in terms of this geometric sequence. And this new sequence is an arithmetic sequence, and we have to show that it is an arithmetic sequence with a common difference in terms of r. So we are given that an is equal to log u1 modulus of u1 base 2. So u1, u2, u3 could be negative. Therefore, log of modulus of u1 to the base 2, where n is a positive integer. Now we need to find the common difference. We will use the general formula for the common difference, an plus 1 minus an. So using an plus 1 into the given expression for an, you will have log of un plus 1 modulus minus log of un modulus to the base 2 for both, and changing the subtraction to division This is what you will get. And go back to the question. Since r is the common ratio, we have r is equal to un plus 1 over un. So this becomes log of modulus of r to the base 2. So we have found that d is equal to log of modulus r to the base 2 here. So we have completed the first question, writing the common difference in terms of r. But have we shown that this is arithmetic sequence? We have not shown that. When we will show this as arithmetic sequences, when we write this as this is a constant, therefore this is arithmetic sequence. So the word constant is important here. Since this value is a constant, it is an arithmetic sequence, and that value is logarithm of modulus r to the base 2. So this is where you should stop for the first question. And for the second question, we have a particular geometric sequence in which u1 is equal to 3, and also it's given that sum to infinity is 4. So we have u1 as 3 and sum to infinity as 4. Substituting in the formula for s infinity, you will get r is equal to 1/4. You can solve this by yourself. Now we have to find the value of d. So d is equal to log of modulus r to the base 2. Now r is positive, so therefore you can leave the modulus sign there. Log of 1/4 to base 3. 1/4 is what? 4 to the power of negative 1, which is also written as 2 to the power of negative 2. And this can be written as negative 2 log 2 base 2, which is 1. Therefore negative 2 times 1 gives you negative 2 as your final answer for D. Now this is all done. It's a very simple question. It might look intimidating in the beginning, but once you start writing it down, it's going to be very simple. The marking scheme, M1 mark for identifying that D is equal to AN plus 1 minus AN. Using that general formula, do not use particular values. You do not substitute U1, U2, U3 and use the values. The marks are given only for general approach. And using the correct rules of logarithms here and getting the value for D in terms of R and writing this word constant gives you one reason mark. So unless you write that this is a constant, you will not get that reason mark here. Simply giving the D in terms of R is not going to help you. You have to write that this D value is a constant. Only then you will get that R1 mark. For question B, method mark for using the S infinity correctly and getting the R values. Substituting the R value into D and getting the correct value for D will give you 3 marks. Let's move on to the next one. Again, this might look intimidating, but it is not. But what you need to see here is this is logarithm base 3, this is logarithm base 3, but here it is logarithm base 2. Therefore, definitely we are going to use the change of base rule. Let's use the change of base rule for the division 2 log 3 base 2. This is nothing but log of 9 base 2. And if I change this to base 3, 9 base 3, 2 base 3. 9 base 3 is 2, we know that. So this is going to be 2 divided by log of 2 base 3. And in the question, it is in the denominator. Therefore, the question will have log of root x base 3 is equal to log of 2 base 3 divided by 2. Therefore, it will be reciprocated in the first term. Plus remaining term, I am writing it as it is. Now every term is in log to the base 3. Using all the rules possible here, half log x for x power half. Dividing by 2, I am writing this as half. And log of 4x cube can be split into log 4 plus 3 log. Writing them all in separate logarithmic forms. And then collecting all the log x together and constants together, we will have negative 5 over 2 log x is equal to log of root 2 times 4. Half log 2 is log root 2. Therefore, log of root 2 times 4 on the right hand side. Collecting all the log x's together, negative 5 over 2 log x to the base 3. Both the sides are to the base 3. Therefore, we can say that log of x to the power of negative 5 over 2 is equal to log of 4 root 2. Simplifying this, because both of them are base root 3s, this is equal to this. And we have this equation for x. Now what is 4 root 3? It is 2 to the power of 5 over 2 using exponential rules. So I can equate this to this. Now on the right hand side, I have positive 5 over 2. I have to make it into negative 5 over 2. For that, I will change the 2 to half. So that I will have half to the power of negative 5 over 2 is equal to x to the power of negative 5 over 2, which gives me x is equal to half. So we are done with the question. We have to solve for the question. We have solved it. Now going for the marking scheme. Changing the base for log 3 base 2 gives you one method mark. And writing the logarithmic equations correctly using all the logarithmic rules, one method mark. Getting the equation in log on both the sides, one method mark. Getting the correct expression for x and half on both the sides with the same powers, one answer mark. And the final answer mark for the x value is equal to half. So we have all the marks here. This is just for 5 marks. Again, lot of rules of logarithms and exponents are being used here. So be thorough with all the rules here. Going for paper 2 question. First question, and this question looks too long for us, but they are not very difficult because all the bases are to the base 10, and it's going to be simple if you make them into log on both sides, simplifying the right hand side to square root of PQ and equating them to this equal to this because both of them are log to the base 10. So I'll write this and squaring on both sides. I'll get the simplified form as p plus 2q the whole square is equal to 8pq. I think you can easily understand all these things. I don't have to explain them in detail because this is just algebra and manipulating the expressions here and there. So p plus q the whole square is equal to 8pq. Expanding p plus q whole square and bringing the 8pq to the left hand side, I'll get this equation in quadratic. This is a quadratic in p because I want to find p in terms of q. Now I will use the formula for this equation because I want p in terms of q. Therefore, p will be the variable and I will use the remaining stuff in the formula. Simplifying this, I will get this value for p as 2q. So, p is equal to 2q is the answer. You can actually identify that this expression is p minus 2q the whole square. If you are able to identify that, the steps would be much simpler. You will directly get p is equal to 2q from there. If you are not able to identify that, you can very well use the quadratic formula and simplify as I have shown here. Let's go for the marking scheme. Writing both the sides in log and log and cancelling the logs and simplifying the expression to this form, you get m1 and a1 marks. And then writing the quadratic correctly a1 mark and finding the final answer for p as 2q a1 mark. As I said again, there is no method mark here. As long as your quadratic is correct and you are able to identify the quadratic either as a square or use the quadratic formula. Either way, if you get p is equal to 2q, you get the direct a1 mark for that. Going to the next question. This question needs a calculator. As you would have noticed, the previous question did not require any calculator usage, but this question needs a calculator. So pick up your calculator and keep it with you. The question says pt is equal to p naught k, that should be t. pt is equal to p naught e to the power of kt. P naught is the initial population. T is measured in decades. Initial population means it is the value for the population at t equal to 0. And t is measured in decades. Be careful about this. Decade is, it's given 1 decade is 10 years on the top. After 1 decade, which means t is equal to 1, it is estimated that p1 by p naught is equal to 0.9. It's given in the question. So using this, I can write that p1 by p naught is equal to e to the power of k times 1 because it is at t equal to 1. So t becomes 1. p1 by p naught equal to 0.9, which gives me e power k is equal to 0.9, which further gives me that k is equal to ln of 0.9. Changing the e power k to ln, k is equal to ln of 0.9. You can leave it here for a1, but I will simplify this to negative 0.105 to answer the next question. Interpret the meaning of the value of k. You cannot interpret when the value of k is in terms of ln of 0.9. When you use your calculator and find the value for ln of 0.9, it is negative 0.105. This gives you that since k is less than 0, since k is a negative number, the population is decreasing. So this is just 1 mark for the question A2. So in order to interpret the meaning of the value of k, you have to find the ln of 0.9. Otherwise, you can leave the answer as ln of 0.9 here. Going to question B. Find the least number of whole years. Now it is given in decades. You have to convert this to whole years by multiplying the answer by 10. Be careful about that. And the question is for less than 0.75. So pt over p naught is less than 0.75. We know that pt over p naught is e to the power of kt. Therefore, we have to solve the equation for e to the power of kt is less than 0.75. Now substitute the value for k here that you found in question A. Use ln of 0.9 instead of negative 0.105. It will give you more appropriate value. Now ln of 0.9 times t is less than ln of 0.75, taking ln on both the sides. Now you have to be careful that ln of 0.9 is a negative number. Dividing by this number will change the inequality. Therefore, t is greater than 2.739, etc. And now this is in decades. For the final answer, you have to multiply this by 10 and give the answer as 28 years. So the least number of whole years for which this is less than 0.5 is 28 years because t is greater than 28 years in this case. This inequality can also be solved using graph. Let's see how it is done using graph here. So this is the graph of e power ln of 0.9x. This is y equal to 0.5, looking for the intersection, and this is the place where it is less than 0.75. And you can see that for all the values of t greater than 2.7305, you have the value of e power ln of 0.9t less than 0.575. This is the same thing using graphical method. So we have solved for this question. Now going for the marking scheme. For the first question A, writing the P1 over P0 in terms of e to the power of k, 1 method mark. Finding the final value for k, 1 answer mark. And a reason mark for writing that the population is decreasing because k is negative. Going to question B, method 1 mark for writing the inequality correctly. Solving any method in the correct way, method 1 mark. Giving the answer for t as greater than 2.739, answer 1 mark. Multiplying by 10 and giving the answer as 28 years is answer 2 marks here. If you don't do this last step, you will be losing both the marks for A2 there. So be careful. It is given in decades, but your answers should be in whole years. You have to multiply the final answer that you get from the calculator by 10 and give the correct answer for that A2 marks. Otherwise, you will be losing 2 out of 5 marks for question B here. I hope this video was very helpful for you to understand the past paper questions on exponents and logarithms. Until we meet next time, thanks for watching. Subscribe, like and share my videos with your friends and families. Happy learning from Ganitika.com.